You know. Yeah, I found this now. Oh, you explain on that phone. You explain so. Wow. Wow. Give. Well, no need no. Sensible.
The process that people part in an electrolytic cells. So what is an electrolyte? What is an electrolyte? Electrolyte is a substance that can and negative ions. The positive ions and negative ions, the anion and electrolyte. Example of an electrolyte you have, and type of electrolyte you have two types of electrolyte. There's strong electrolyte and the weak electrolyte. So under the strong electrolyte, there's no electrolyte. Strong electrolyte are substances that can
Who's the matter?
completely. These are substances that can dissociate completely to give positive anion and cation in their ionization state. Example of strong electrolyte, you have sodium chloride.
What's the marker?
You have sodium chloride, potassium chloride, silver nitrate. Weak electrolyte. These are electrolytes that dissociate partially in water. You give anion and cation. Example of weak electrolyte, you have all the organic acids, such as the ethanoic acid. They are weak electrolytes. So, example of the dissociation of a strong electrolyte, sodium chloride, dissociate in water to give sodium ions, sodium plus ions, sodium
Ions plus.
and the chlorine ion. So this is complete dissociation because here I have the ion of sodium, I have the ions of chlorine. There's no attachment of other molecules. So other weak electrolytes, like example, ethanoic acid. The ethanoic acid we dissociate the water to give the amplified ions plus the hydrogen ions. So this is partial dissociation because you have other molecules attached. You have the oxygen, the carbon attached to this other compound. So this is a weak electrolyte. Now under electrochemistry, this we deal on cells, type of cells. There are two types of cells in this. You have the galvanic cells and the electrolyzer.
Electrolytic cells.
The electrolytic cells. But now we are going to deal with the electrolytic cells. In the galvanic cells, the electrolyte is capable of conducting electricity without the supply of an external source of external voltage source. Meanwhile, the electrolytic cells, the electrolyte, the voltage source is applied to the electrolyte from an external source. So this one is now electrolytic cells. So now under the electrolytic cells, we have the component of the electrolytic cells. We have the electron. So in the electron, we have two types of electron. We have the cathode and the anode. So now the anode is positively charged, and at the anode is where oxidation takes place. And the cathode is a negatively charged, and it's where reduction takes place. So when sodium chloride, taking sodium chloride as an example, is being placed in the electrochemical system, in the electrochemical cells. So sodium is having sodium ions, the positive ions, will migrate. The positive ion will migrate to the cathode, and this will be the equation. Because migrate to the cathode, where yes, migrate to the cathode. At the cathode, this is where reduction takes place. So sodium ion is going to be reduced, which means that sodium ion is going to gain electrons. Sodium atoms. This process is important. Okay, I will see that under the diagram of electrochemistry. So then meanwhile at the anode, the chlorine ion is going to migrate in the anode compartment. In the anode compartment, since the anode is positively charged, from the law of electrostatic, like charge reverse and unlike charge abstract. So the positive charge and the positive anode, the anode will attract the negative charge, which is the chlorine ions. So chlorine ions is going to be oxidized in molecule. For now, this is one more. So chlorine is a bimolecule. So now we have to close by. Let me just take in the form of this. So this will be in the form of oxidized chlorine molecule. So this is the last on the component of an electrochemical cell. So now from there now, electrochemical cells move to conductivity. Move now into conductivity. Conductivity, what is the conductivity of the substance? The conductivity of the substance from the Coverage law, the PDS, the Coverage law, the conductivity of the substance is the sum of the individual contribution of the anion and the cation in the electrolyte. So the anion and the cation, they are the sodium ions and the chlorine ions. So this is the Coverage law, presented as the form of this. The anion, the contribution of the ion and the electrolyte. We have the anion and the cation. So now from there, we have other conductivity. We have conductance. What is conductance? Conductance is the flow of electricity through a solution. Okay, this solution is known as an electrolyte, which has positive and negative charge, the anion and the cations. So now under conductance, we move on how to calculate conductance. Conductance, for us to calculate conductance, we have to look for the resistance. So what is the resistance? The resistance is the current offered by a conductor of length 1 centimeter and area with a unit cross-sectional area. So for here, resistance, to calculate conductor resistance is equal to resistance is directly proportional to the length of the conductor, which is L, and inversely proportional to the cross-sectional area of the conductor, which is A. From there, for us to calculate conductance, the conductance is the reciprocal of the resistance, meaning that conductance G is equal to the reciprocal of the conductor 1 divided by 1 divided by resistance. So this is the conductance. Now we move under the types of the unit of conductance. The unit of conductance is measured in ohms. Since resistance is measured in ohms, taking the reciprocals, meaning that conductance is the ohms. So now another type of conductance we have the molar conductance. We have the other type of resistance we have the specific resistance. So in the specific resistance, we work out try to find out the specific resistance by using the general formula. Resistance is equal to rho. Resistance is equal to rho directly proportional to area and inversely proportional to the cross-sectional area, which means that where rho is the specific resistance, which means that rho times cross-sectional area divided by length. So the specific resistance, given the definition of the specific resistance, the specific resistance is the current offered by a conductor of length.
Please, who are those in group?
A unit
You are not submitting your assignment in the group.
of length with a unit cross-sectional area. So this is our specific resistance. So now, the formula of specific resistance is on meter. So now we are moving now to specific conductance. A specific conductance is still the reciprocal of the specific resistance, which means that specific conductance J is equal to the reciprocal of rho, which is equal to 1 divided by meter, which is equal to 1 per meter. So that is the unit of the specific conductance. Now we move now to the molar conductance. What is the molar conductance? The molar conductance is the total conductivity power of the anion. Or the molar conductance is the total conductivity power of the anion and cation in the electrolyte. So that is the molar. The molar conductance is the total conductivity powers of 1 mole of an electrolyte in a solution. So now the formula for calculating the molar conductance, you have to first of all know the specific conductance, which is K times 1000 divided by molarity. So this is the formula to calculate the specific conductance. Like in my PDF, you have many equations under this. So this is the formula to calculate the specific the molar conductance. Now move to the equivalent conductance. The equivalent conductance is the total conductivity powers of 1 gram. Is the total conductivity power of 1 gram of the electrolyte in a solution. So the formula to calculate equivalent conductance is still you have to look for the specific conductance. So the specific conductance times 1000 divided by normalities. In equivalence conductance we deal with normalities. So now the normalities in the exam they are going to give the normalities. But in molarity is the same like concentration. Mole divided by volume in cm. So now that is other conductance. Now you can be asked to calculate the cell constant. For you to know the cell constant is having a dimension of a meter. So the cell constant, for you to have the cell constant, you have to take the specific conductance, which is 1 meter, divided by the conductance G, which is divided by conductance, which is the ohm. So this will give you the formula of the unit of per meter, the unit to calculate cell constant. Okay, from our definition, distance is equal to L divided by area. Here is is our specific conductance. Here, length divided by area is always the self-conductance. So you can see this formula is only the self-conductance. This will give you the unit of per ohm in the self-conductance. I mean per meter in the self-conductance. So now under this now we are done with conductance in resistance, conductance, specific resistance, specific conductance. Now we move now how to calculate the given mass of a substance. Okay. How to calculate the mass of an ion in an electrolyte. For example, they ask, okay, 0.2 ampere of current is being applied to a solution of like at 6 minutes. 6 minutes of time. 6 minutes. They ask you to calculate calculate the number of moles of sodium ions. What you have to do is you have to first of all write the cell equation.
Hold on, please.
You have to write the cell equation. So now they have asked you to calculate the number of moles of sodium ions equated. Now you are dealing with sodium. So you have to place now sodium now is having a positive charge. And by the law of electrostatics, the like charge will always be there, unlike we attract. So this means that sodium is a positive charge to move to the negative cathode. Move to the negative cathode. Where the negative cathode is the negative electron. Where the negative electron is the cathode. So reduce the equation sodium plus which is being reduced at this cathode. Give sodium molecule. So from there now, one mole of sodium ions. One mole of electrons with 1 mole of sodium ions to form 1 mole of sodium atoms. Mole. So from there now, this is the mole. Now we have to calculate the number of this oil. We should calculate the number of calculate the number of since you are going to find the mole. Okay, let me check to calculate the number of mass of sodium equated at the cathode. Let us see the question like that. Okay, so here now we have to move now to calculate the charge. You have to calculate the charge. You have to calculate the charge applied. The charge applied to create 1 mass, 1 mole of sodium atom. So from here, current. What is current? Current is the rate of flow of charge, which means that current divided by time is current. Which means that time times is equal to column. Here we have the time, we have the current. So we take 0.2 ampere times 6 minutes. We have to convert our minutes into seconds. So we take 6 minutes times the second constant, which is 60 seconds. So 6 minutes times 60. Someone should want the calculator and let me know. 6 minutes times 60 will give us our and we multiply it by 60. Okay, 360. Okay, 360 times 0.2 ampere. That will give us our column. Someone should let me know. 360 times 0.2. 360 times 0.2. Okay, this will give us 72 columns. So this will give us 72 columns. Okay, now here it comes now to appreciate one of our scientists, our colleagues, Michael Faraday. The Faraday. So now, for us to use the Faraday, we have to find the constant, you have to use the charge of an electron, which is 1.6. 1.6 times 10 raised to the power 19 times columns times the Avogadro constant.
Last time why?
1.6 times 6.02. This will give up 1.6 times. No, give me one. Find a constant. Okay, this will give you something like 9.6 times 9.6 to 1 decimal places times 10, 23, negative 19 plus 23, that is plus 64. This is the power 4. So this is the Avogadro constant. Yes. Now you have got the Farad.
Yes.
From here, the Farad is in 1%. Here is the Farad. You can put the Farad going to columns.
Oh, where's the yes? Oh, it's good to hear.
Columns the mole. Columns mole. This is the Farad the Avogadro constant is.
Avogadro's constant is measured in per mole. It can be atoms per mole, molecules per mole, ions per mole, and so on.
Okay, per mole. So this will give 9.6 columns per mole. So now, from here now, you have the columns here. These are the columns. 72 columns divided by 9.6 times 10 is the power 4. Here is the dimensions. The various quantities. That columns, this one will cancel this one. This will become in the form of. This will become in the form of mole. The dimension will become in the form of mole. From there, take 72 divided by 9.6 times 10 raised to the power 4. And this is the answer. 72 divided by 9.6 times 10 raised to the power 4. So now, our demonstration is already in mole.
7 point something times 10 to the power negative.
Okay, let us take 7.
And 10 to the power what?
Times 10 to the power 4. Yes. 7. It will be 7 point something times 10 to the power negative 4. Okay. Times 10 to the power 4 moles. This is our mole that we have here. So yeah, this is our moles. Now we are asked to calculate the mass of sodium ions. From here now, from the equation, mole is given by given mass divided by molar mass. Now, we are asked to calculate the mass. Which means that directly we are asked to calculate the given mass. So now we know the molar mass of sodium. Sodium has the atomic number of 12. Sodium has the atomic number of 11. So 11. So you have to add 11.5 times 2. This will give us 23 grams. This is the molar mass of sodium. So making this the subject of the formula, which means that mole is equal to mole times molar mass. To give us the mass that we are finding. So we have to take 7 times 10 to the power 4 times molar mass, times molar mass of sodium, which is 23. This will give us the 23 grams per mole. Molar mass is 23 grams per mole. So this mole will cancel this will 11 grams. So this will give us the mass that we are supposed to when we are asked to calculate. So that will give us our answer. So that is under that. But this is there's no time is short. The PDF is there. You can revise it. So I will move now to the importance of electrochemistry. Under importance of electrochemistry, electrochemistry is important that some substance is difficult to be extracted through chemical process. Okay. So now, in the sense of electrochemistry. For example, for the extraction of the group 1 elements and the group 2 elements, due to the fact that the group 1 element and the group 2 elements they are found in combined form in nature. For example, for you to find sodium, sodium is extracted from salt water, which is sodium chloride, combined nature with halogen. So between the principle of electrolysis, where we put it in an electrolyzer, and the sodium will move to the cathode, where the pure sodium is being extracted, and the chlorine can migrate to the anode, where chlorine can also be extracted. So now, second use of electrochemistry is also used for the purification, the refining of metals, the refining of new metals. For example, aluminium. For you to refine aluminium, aluminium exists in its combined form in its ore known as bauxite, aluminium tetraoxide. So now we have to use the principle of electrolysis that is under the brine cells, where pure aluminium can be decomposed with the principle of decomposition, where we can decompose the aluminium tetraoxide to give us pure aluminium. So this is under the process of electrochemistry. So I'm very, very happy on this. So colleagues, what application are you going to give in the principle of electrochemistry under as a part of physical chemistry? What application are you going to give in the principle of electrochemistry? Thank you, colleagues.
Last meet there.
Okay, you want to